So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now. So the main agenda for today's session, we are going to discuss on the market basket analysis here, how the association rule mining works, and how the a priori algorithm works. A small question that we can start with is, has it ever happened that you are out to buy something and you end up buying a lot more than you have planned? So this normally happens in the marketplaces, correct? So it's a phenomenon called as the impulsive buying, and big retailers take advantage of machine learning and a priori algorithm to make sure that we tend to buy more. And that's what we have defined as a market basket analysis. Now, first of all, let's discuss on that. So in today's world, the goal of any organization is to increase the revenue. And can this be done by pitching just one product at a time to the customer? The answer is clearly a no. Hence, the organization began mining data related to frequently bought items. So market basket analysis is one of the key techniques used by large retailers to uncover associations between items. So they tend to find out the associations between different items and products that can be sold together, which gives assisting in right product placement. Typically, it figures out what products are being bought together, and organizations can place products in a similar manner. Now, let's understand this better with an example. Let's say we have people who buy bread usually buy butter too. So the marketing team at retail stores should target customers who buy bread and butter and provide them an offer to them so that they buy the third item that we have, eggs or any kind of jam as well. Correct? So if a customer buys bread and the butter and see a discount or an offer on eggs, they will be encouraged to spend more and buy the eggs. So this is what market basket analysis is all about. So this is a small example. Let's say if we take 10,000 items data of our supermart to a data scientist, just imagine the number of insights we can get out of it. And that is why association rules mining is also important to understand. So if we talk about association rule mining, then association rules can be thought of as an if-then relationship. Suppose we have an item A. So item A is bought by the customer, and then the chances of an item B being picked by the customer too under the same transaction ID is found out. So here we have simple if and then relationship. So there are two elements of these different rules. First of all, we have the antecedent as an if. So this is basically an item or a group of items that are typically found in the item sets or data sets. And then we have the consequent, that is then. So here we have then. So then is basically used for, then it comes along as an item with an antecedent, or we can say a group of antecedents that we have seen. And antecedent we have discussed, it is basically an item or group of items that we found in item sets of data sets. Now, here comes a constraint. Suppose we made a rule about an item we still have around 9,999 items to consider for rule making. As we discussed, we are going to make use of 10,000 items. So this is where a priori algorithm comes into play. So before we understand the a priori algorithm, let's understand the main mathematics involved here. So there are three ways to measure the association. We have support, confidence, and then we have lift, through which you can measure the association here. We have support, confidence, and lift. So support gives the fraction of transactions which contain item A. Suppose if we talk about support here, it is basically the fraction of transactions which contains item A and B. So basically, support tells us about the frequency we can say frequently bought items or the combination of items bought frequently by using the support. So with this, we can filter out the items that have a low frequency. Then we have confidence. So it tells us how often the items A and B occur together, given the number of times A occurs. So typically, let's say when we work with the a priori algorithm, we define different terms accordingly, but how exactly we have to decide the value? That's the main question. And to be honest, there is not a specific way to define these terms. Suppose we have assigned the support value as 2. Now, what exactly this means is until and unless the item frequency is not 2, so here we define support as 2. So until and unless the item's frequency is not 2%, we will not consider that item for the a priori algorithm. So this makes sense as considering items that are bought less frequently is a waste of time. Because let's say if only 2% of users are buying this item along with the item that they have bought, then obviously they cannot use it. We cannot even consider it for the a priori algorithm that we are going to work on here. Now, suppose after filtering, we still have around 5,000 items left. Now, creating association rules for them is a practically impossible task for anyone. And this is where the concept of lift comes into play. So basically, lift indicates the strength of a rule over the random occurrence of A and B, and it basically tells us the strength of any given rule here. So for finding that out, we have to simply divide support by the support of A and then support of B. So focus on the denominator. It is the probability of the individual support values of A and B and not together. So lift explains the strength of a rule. So more the lift, more is the strength. Let's say A, suppose we can say for A is to B. So if then relation, so if we talk about if then relationship for AB, then the lift value is 4. So first, let's say for this relation, the lift value is 4 here. That means if you buy A, then the chance of buying B is 4 times. If the lift value is 4, or we can say it's 4 times. If the value here is 2, then it is 2 times, and so on, as a part of the lift values defined. So let's get started with the a priori algorithm, and now let's see how exactly it works. All right, so now let's discuss on the this is what we discussed here, the transactions at our local market. And here we have ABC for in transition 2, we have ACD. In transition 3, we have BCD. In transition 4, we have ADE. And then we have in transition 5, we have BCD. So let's say here, if you find out the entire rules here, then if A, then again, they are going to purchase D. If they buy C, again, they have the option of going for A. If they buy A, then they have the option of going for C. And if they buy B and C together, then they are going to buy A as well. And then same way, we can find out the supports. So again, for if A is, for those who are purchasing A, the probability of buying D, it is in terms of support, it is 2 by 5. In terms of confidence, it is 2 by 3. In terms of lift, it is 10 upon 9. Whereas for C, again for A, that means what is the possibility that those who have purchased C will be buying A. So you can find the support as 2 by 5, confidence as 2 by 4, and lift as 5 by 6. Same way for C and same way for BC and A. So we can see how the probability is going to be distributed as we find out the possibility of one product to be bought over the other. All right, so now let's assume further on the a priori algorithm part. So a priori algorithm uses frequent item data sets. Okay, so item sets or data sets to generate the association rules. So it is based on the concept that a subset of a frequent item set must also be frequent item set, must be a frequent item set. And frequent item set is an item set whose support value is greater than a threshold value that we have support. So let's say we have, now we're getting what exactly a frequent item set is, what we discussed just now. It's an item set whose support value is greater than a threshold value. All right, so now if we talk about a simple example, now here we can, let's say we have the following data of a store here. So we have the transaction ID here, and then we have items. So here we have these one are transaction IDs, and here we have the items. So in transaction one, we have 134, 235, 1235, 25, and 135. So if we talk about the first iteration, now let's assume the support value is 2, and then we can create the item sets of the size 1 and calculate their support values, as you can see here. So as you can see here, the item 4 has a support value of 1, here, which is less than the minimum support value. So we are going to discard 4 in the upcoming iterations, and and that's how we can have the final table defined here as the fn. So here we are going to discard the value as 4, and then we are going to have the final value to be given to us. So the item sets with support value less than minimum support value, that is 2, are going to be eliminated. Next, we are going to create the item sets of size 2 and calculate their support values. So all the combination of item sets in F1 are used in the iteration here. So here we have C2, and then we have the F1 here. So basically, here we are going to make use of the entire iteration here, and item sets having support less than 2 are eliminated again. And in this case, we have 1 and 2, right? So let's now understand what exactly do we mean by pruning and how it makes a priori one of the best algorithms for finding the frequent item sets. So if we talk about pruning, then we are going to divide the item sets in C3 into subsets and eliminate the subsets that are having a support value less than 2 from this given item sets here. So here we are going to work on the third iteration. So we will discard 1, 2, and 3. We are going to discard 1, 2, and 3, and 1, 2, and 5 as well. So they both contain 1 or 2. And this means again, and this is the main highlight of the a priori algorithm here. So again, here we are going to discard 1 and 2. And this is the main highlight of this entire algorithm here, because again, the 1 and 2 is a common thing available in these both data sets, right? So this is the main highlight of a priori algorithm here. And then if you talk about the fourth iteration, so as you can see, if any of the subsets of these items that are not in F2, then we are going to remove that particular item sets. And then in terms of the fourth iteration, let's suppose here we have the transaction ID, and here we have the item set and support available. So since the support of this item set is going to be less than 2, so we will stop here, and the final item sets will have is the F3 one. And now, still now we have not calculated the confidence value yet. So again, this is something that we have to keep in mind. So with F3, we get the following item sets. That means for 1, we have 1, 3, and 5. And subsets are 1, 3, 1, 5, 3, 5, 1, 3, and 5. Whereas for item sets 1, again, we have 2, 3, 2, 5, 3, 5, 2, 3, and 5 itself for the other item sets available. So for 1, we have 1, 3, 5. These are subsets of 1, 3, 1, 5, 3, 5, 1, 3, and 5. Whereas 2, 3, 5 are subsets of 2, 3, 3, 5, 2, 5, 2, 3, and 5, right? And for every subset of I, we have to define the output rule. Now, when we are going for applying rules here, so we will create the rules and apply them on item set F3. So now let's assume a minimum confidence value is 60%. So for every subset of that we have S of I, so the output rule is going to be S is going to be recommended. So S is going to simply recommend IS, and then we hit support, it is I, and then we can simply divide this by the support cell, and to find the minimum confidence value is going to be 135. So here rule 1 here is 1 3 is again a subset, that means 1 and 3 will result to 5. That means if a user is purchasing 1 and 3, both the items, then we have a good possibility of the customer going for the 5th item as well. So here the confidence is going to be support 135 divided by support 13, that is 2 by 2, that is 66.6%, that is 60%. So here rule 1 is going to be selected. And in rule 2, we have 1.5, 1.35 minus 1.5. That means if someone is purchasing 1 and 5, then they are going to have a good possibility of going for 3 as well, where we are going to see the confidence. And for finding the confidence, we are simply going to again subtract support for 135 by support of 1.5. That's 2 by 2, and this is going to simply be translated at 100%, and which is much greater than 60% as well. And same way in rule 3, we have 3.5, 135, 3.5. That means here, if someone is going for purchasing 3 and 5, then they are going to high possibility of going for 1 as well. So here the confidence is support 135 divided by support 35, that we get as 66.66%. And here the rule 3 is going to be selected here, as you can see here. Now, upright. Now, if you talk about the application of rules here, now when we are talking about this rule here, we can see whenever the confidence is going to be more than 60% defined here, then this rule is going to be selected. As you can see here in this rule 5, where those who are purchasing 3, they have a possibility of going for 1 and 5 both. So here the confidence is less than 60%, which is why this is going to be rejected. Same way for rule 6 as well. Same here for rule 6 as well, because here the confidence is going to be less than 60%. Then that's why this is going to be rejected here, correct? Because again, here we have assumed a minimum confidence level for 60%, and wherever we are going to get the confidence less than 60%, we are simply going to reject that particular model here. All right. So first of all, that's how we had seen how we can create rules in Apriori algorithms here. And the same steps can be implemented for these item set 2, 3, 5. And then we are going to try it and see which rules are accepted and which rules are going to be rejected, and how we can implement the a priori algorithm in Python. All right, so let's fetch some sample data sets here that we are going to work on. So to get started working on the actual analysis here, we are going to make use of the PyCharm ID. So we can use any of the ID, or we can also make use of the Python common IDLE to get started. So we are going to make use of PyCharm. In this file, we'll be having the access to the invoice number. We have the stock code, we have description, quantity, invoice date, unit price, customer ID, and then we have the country. So this is a data point, that this is a file that we are going to work on. All right, so in the meantime, we are also going to install PyCharm as our main ID. So in case you want to work on Python, then we can make use of PyCharm ID, which is one of the most popular IDs for getting started. And PyCharm is also offered as a free tool. That means here it is also offered as a community tool here. So you can use it as a community tool in order to get started. So once we have the access to it, we can open this up. All right. So here we can get started. First of all, we are going to work on the pandas library. So here we are going to import pandas and MLXten libraries imported and to import and read the data sets. So here we are going to use import, and then here we are going to find import pandas, and from pandas as PD. So here we go to import pandas as PD, and then we are going to use from MLXten, we are going frequent patterns. We are going to import a priori, and then we are going to use the same from MLXten frequent underscore patterns. We are again going to import association rules. We're going to import association rules, and then we are going to create a data frame where we are going to make use of pandas library as pd.read, and here we are going to read Excel file. If it is a CSV file, then we define it as read CSV, and here we can define the path. Suppose here the file is currently available in our users location, and under users we have it in downloads and by the name of online underscore retail dot xlsx. So this is the library that we have currently imported here. And in case suppose some libraries are currently missing here, so we can import these libraries as and when required here. Suppose if something is missing here, we can simply import these libraries in case they are not properly installed. So for installation of any new library here, we can go to File, under Settings. Here we have to go to Project Interpreter. In case you want to add any specific library here, then we can simply click on plus, and then we can choose which all library we want to add here. We can simply see the entire list of all the libraries currently installed here. And now if we want to start with more, then we can simply add more libraries, and then we can start deploying it one by one. So for example, suppose if we want to install any specific library here, so here we can, let's say here we want to install the a priori here. So we can see here we can also import the ML extent. So if this library is currently available, we can simply click on install package, and this is going to be installed and stored in a system as a library. Same way if you are looking for a priori here, so here we can also use, because again at the end we are going to use a priori from the ML extent that we have imported. So here we are going to install the other package as well. So the first package for ML extent has been installed, and now if you want to install the other packages, then we can also install it. So in case we have missing some kind of library, then we can simply install it, or in case we have not used those libraries here, then we can simply use them one by one. So once we are done, we can simply come out. So as you can see now, once the libraries have been properly installed, then we'll be able to see there is no error being shown here. And this is the path of the file where we have stored online retails.xls file here. So just to confirm, we can confirm that we do have the file by the name of online retail.xlsx available here in our downloads directory. So once we have specified the file here, and then we are going to simply use dataframe.head. So in case we want to see the first few entries of the current data set that we have imported, so here we can simply define df.head, and then from the given path, the first few head is going to be returned back as a response. Now once we are done, we can simply start applying it. Now once we have the access to the data set here, next step is going to be focus on data cleaning, which will include removing spaces from some of the descriptions that we have. And for that, we are simply going to specify here we can, now instead of using the data frame head here, so now we are going to use the data frame, and then from here we are going to add a short description. So here we can add a short description here. So basically we are going to work on data cleanup, which includes removing spaces from some of the descriptions, and then we are going to drop the rows that don't have invoice numbers and remove the credit transaction as well. For example, suppose we have some rows where we don't have where we have blank transactions itself, right? So we have some blank invoices, and then we have invoices numbers, and remove the credit transaction where we don't have any kind of invoice number placed here. All right. So here we have to work on removing those kind of anomalies. So here from the data frame, so here we can add parameter as description. Now under description, we are going to use a string function as string dot strip. So string function is available under string. We're going to make use of it. And then same way from data frame, we are going to work on dropping. There we can find the values for x is equal to 0, and then the subset where what kind of values we have to drop. Do we have to define that parameter where the invoice number is going to be in place, is going to be true. And then from data frame, we can define the invoice frame, the invoice number, and then we can define it to be a data frame where invoice number, again we are going to convert that to a string itself. So here we can define data frame, and then the invoice number type. So here we have invoice number dot the AS type, and then we are going to the SD type here, but again here we can keep it to AS type. So here we can define to be a string value. So here we can define to be a string, and then we can create a data frame where we can define data frame should be a value closer, or a value closer to data frame where we are going to define the invoice number. So here we have invoice number, and then we can define this as a string point We missed on the, so here we have string dot contains, and then we can define wherever the value is C. Wherever the value is C as a part of definition defined here. And then we are going to simply save it as a part of given data frame. So after we are done cleaning up, we need to consolidate the items into one transaction per row with each product. So for the sake of keeping the data small, we are only going to be looking at the sales for any specific country. So now once we are done, we are going to create and consolidate the items into one transactions per row with each product. And for the sake of keeping the data set small, we are going to look at the sales for a specific country. So for that, let's say here we want to focus on one country data set here. So here we can use basket. And then in the basket part here, we can define multiple data frames. For example, first of all, we can define data frame. And here we are going to use the same data frame. And then we are going to segregate it further based on the country itself. So here we can define country, and then under country, we can define which country we want to focus on. The country should be, suppose, let's say France as a single country. So here we can define France as a country that we want to use for consolidation. And then we are going to group. So here we can use group by the invoice number. So here we are going to define the invoice number for it. So here we have invoice number. And then we can add a short description here. So here we can add description. And then after we are done defining the description here, we can then define the quantity here. So here we can define quantity. And then after quantity, we can define sum. Let's put this underline just to avoid the confusion. So here we can define sum. And then we can define unstack dot reset. We missed one other parenthesis here. So here we have to define sum, and then we have defined unstack, and then we have defined dot reset, and then the index value here with the final NA, with the final, or we can say with the simple fill color, with the simple fill, and then we can define the value to be a simple 0. And then we can use set underscore index, where we can define for the invoice number. So here we have invoice number defined. And then we can define this for a basket. So basically here we are going to define the consolidation for the items into one transaction per row with each particular product. And to keep the number of transactions low, we have focused our attention only for a single country itself, as in France. So after we are done with that part, next we have to work on removing all the zeros. So basically there are a lot of zeros in the data, but we also need to make sure that any positive values are converted to a 1, and anything less than 0 is also set to 0. So for that, we are going to make use of this. So basically here we are now for converting that, here we are going to go ahead and perform the encoding as well. So here we can define encoding units. So if x is less than or equals to 0, then we are going to return 0. And if x is greater than or equals to 1, then it is going to return 1. Where we are going to define the basket sets and the basket apply map encode units. And then we are going to simply use the drop postage and in place set it to be true here. So basically here we are going to simply work on, first of all, removing all the anomalies here. And then if there are a lot of zeros in the data, we also have to make sure that any positive values is converted to 1, and anything less than 0 is also set to 0. That's what we have done here. And then we are going to generate a frequent item set that have support value of at least 7%. And this number is chosen so that we can get close enough and we don't observe any kind of errors, or we don't get any errors thrown. And here we can generate the rules with the corresponding support, confidence, and lift. So for doing that, we can make use of frequent item sets. So here we are going to define frequent item sets where we are going to define the a priori from basket set. Minimum support should be 0.7 and the call length that are going to be used should be true. And the rules here defined should be for association rules where we want to define the metric as lift and the minimum threshold to be set to 1. And then we are going to filter the data frame using standard pandas code for a large lift and high confidence value as 0.8. And then if we run this, and we'll be able to see the output directly in the section altogether. So here we can simply run the rules. And then if we run rules here, we can define rules for lift. It is going to be defined as a value greater than 6. And the rules where confidence value is going to be 0.8 altogether. So that's how we can make use of the a priori algorithm here. So as it's almost time now, so let's do one thing. Let's say we wrap it up for today, guys. Thank you.